Hello, everybody, and welcome to our webinar on updating the design process for successful net zero energy buildings and about net zero generally in Denver. We do have a poll up, so hopefully we can tell who is on the call today. And if you could answer that, we'll go over it in a minute. So for quick introductions, I'm Amber Wood with the City and County of Denver and part of our Office of Climate Action, Sustainability, and Resiliency. We are partnering on this webinar as well as on our 2021 code adoption process with NERESCO. And I have with me today Kevin, Axul, and Erica, who are all going to take parts of the presentation as well. So just as a basis, we do want to just kind of start with the statement that net zero energy buildings are healthier, more comfortable, lower cost, and going to make Denver more attractive and competitive. So we asked you the question of who's on the call today. So we have a lot of building officials. Thank you so much for showing up. And then a number of other members of design teams like engineers, architects, and energy consultants. So to go through the learning objectives, we have a number of them, and they're really all around net zero energy. So what is it? And then what are the costs? And we're going to go through some case studies and how net zero has been successful, some design process changes, and then how can different entities that are part of the design process begin the path, and then how you can get involved and help shape net zero energy in Denver specifically. So this is what we're going to go through. I'm going to start with our climate goals, and then we're going to talk more about the costs of net zero and go through some case studies, as well as the integrated design process, and then what to expect next. So let's get a little into our climate goals. We'll go through these quickly. And while we're doing it, did you know that Denver is pursuing net zero energy? We were just curious if you all are familiar with what we're doing. We'd love to hear about that. And so we want to start by acknowledging, or I would like to start by acknowledging 2020 and 2021, and that we are really thinking through how sustainability can be a combination of equity, viability, and affordability for Denver. So we just want to make sure that we're looking through that lens as we start to talk about net zero energy and where we're headed for new buildings and homes. And great news. A lot of you already know that we're working on net zero. There's a few that don't. So welcome to this. Hopefully we help kind of clarify what we're doing with net zero as well as where we're headed. So we have a couple climate action plans. The 80 by 50 climate action plan details our goal of getting to net zero by 2030. And part of that was also because of the climate action task force that met last year. So we have 2020 recommendations from them on really how to solve climate change in Denver across a number of topics, buildings and homes included. So building and homes, and the reason we're talking about this is because they account for 64% of Denver's 2019 basic greenhouse gas emissions. And as you can see then the slide breaks it out. So 49% of that are multifamily and commercial buildings. We want to note too that obviously Denver's growing significantly, and so here's a number. Here's the projected new construction market, including both commercial and multifamily, which apartment and condos are at the top, and then we also have a number of single-family houses being built as well. So this is what we currently have. Just to note, so multifamily and office buildings really represent the largest building types that we currently have, as well as you saw in the previous slide, a lot of our growth is in the multifamily area as well. So we put together a plan, net zero energy new buildings and homes implementation plan of how to get to net zero energy by 2030. And this shows the path that we're looking to do for commercial multifamily buildings. It also shows context of where we're at with the 2019 Denver Energy Code and the Denver Green Code, just to give some context. The goal obviously is to continue along the trajectory until we get to net zero by 2030 for new buildings, as well as new homes, which is the next slide. So we have a separate trajectory for residential as well. So you can see that here. So I'm going to pass it off. So the costs of net zero is coming up next.
Thanks, Amber. So this section will cover the cost of net zero energy and these topics below. So you might ask yourself, how can you achieve, or your project achieve, net zero energy and still stay on budget? Well, there are some incremental costs. However, those should be offset by the overall building life cycle and its energy cost. So you might see an increase in first cost in order to get better efficient equipment or materials or designing. However, that energy savings produced by those should offset the first cost. So I'll ask a poll question here. How much more does a net zero energy project cost on average? So in your mind, how much more do you think achieving a net zero energy project would cost? There's a lot of different perceptions out there that it costs quite a bit of money, a premium to go net zero energy, but it'd be interesting to see what you all think a premium would cost on going net zero energy. So we'll pull up the answers there, and the answers look like most of you think it's between 10 and 20%, and then the next closest between 5 and 10%. A few of you thought that it might be more than 20%, but in actuality, those of you who picked between 5 and 10 and 10 and 20, you are correct. Based on an affordable housing interim report, which interviews developers, they're seeing about a 10% premium to their cost to build net zero energy. So actually, it's between 8 and 12%. So if you take that out, it's about a 10% premium. However, we've seen several projects not have a premium at all, and that's due to how they approached the net zero energy projects from the get-go. So here are some ways we have seen these net zero projects keep on the original budget and not see those premiums that I previously mentioned. It really takes buy-in from the team and setting realistic goals early on. If everybody isn't on board at the beginning, then it'll be more, or even throughout the whole project, it'll be more difficult to achieve net zero energy. There also needs to be an investment in energy modeling early on in the design phase. It doesn't cost that much to make design changes early on. However, the longer you wait, the more costly those changes are. But the modeling actually helps you predict if you can achieve net zero energy on the budget you're looking at. So both of these items you and your teams might already be doing, which is great. And it's also a testament that this change to net zero energy design practice shouldn't be that big of an undertaking. You know, we see projects that take this time early on. We see those projects being more energy efficient overall during the process or after the building is built. So here's a case study that looked at what an all-electric project would look like from a budgeting standpoint. You can see on here it says that a single-family home, the upfront costs are actually 27% lower to build. And then for a commercial building, the upfront costs are 8% lower to build. So you might find that interesting that, you know, during that poll, we thought that there was a premium between 8 and 12% to build net zero energy. But we're looking at all electric in this case study. So it's not necessarily net zero energy, but all electric. It is actually cheaper or less expensive upfront cost to build. Next slide. So that might come as a surprise, but there are significant savings in the infrastructure costs not needed for the mixed fuel. There also are some incentives from Xcel Energy on rebates. So all electric is an option. This is a residential cost study on the screen. And then the next slide here is an all-electric multifamily cost study. So you can see that, again, the key items here are not needing the gas interconnection and infrastructure in place, and then also Xcel Energy's rebates or incentives. So we see that the keys to keeping a net zero energy project on budget or even below budget is with an all-electric building. And that all-electric building has those savings in the infrastructure and the energy efficiency equipment. So we got to also keep in mind an early commitment with the whole project team is also a key to that. So in this next section, we're going to define what net zero energy is in Denver. So how would you define net zero energy? Select all that apply. So while you're filling out this poll question, you might be scratching your head asking, well, Kevin, why are we talking about all electric buildings? I thought this was for a net zero energy presentation. Well, it is, but it's about the cost of net zero energy. And so this might be a clue to this poll question. All right, so most of you have answered the poll question, being that in order to achieve net zero energy, you need on-site renewables, and then closely followed up by highly energy efficient. So I will say that you are not wrong on that. You are correct. So let's look at what Denver's definition is for net zero energy. And it's on the screen here. A new building or home that is highly energy efficient, which you will have picked in your poll, and fully powered from on-site or off-site renewable energy. Again, you pick that in your poll as well. So then they go out and call out 4 specific items: highly energy efficient, which actually is a target energy use intensity, or an EUI, if you're familiar with that, for commercial buildings, and a target energy rating index, an ERI, for homes. So buildings will have to perform as designed for that building type. So the number 1, highly energy efficient, is energy efficiency is the step that makes everything more cost effective. Then we go to item number 2, which is all electric. And all electric reduces greenhouse gas emissions through all electric equipment in buildings, and would mean no more natural gas in our new buildings and homes. Again, these are all Denver's definitions. So number 3, powered by renewable energy and electricity. On-site or off-site renewables are to be used to focus on additional energy production. RECs will be retired and not sold. So by the 2050 goal is to have the grid be 100% renewable, and buildings are part of the equation. And then item number 4, provide demand flexibility for grid. So energy storage, grid integration, and flexibility to respond to different grid signals. So this is what Denver has defined as net zero energy. The guiding principles to Denver, for Denver to get to net zero energy are incentives, equitably supported construction. So as a whole building community, as a whole community of buildings, we want to achieve this goal. We won't be able to achieve it in every single building or home, which means that some buildings and homes might have to achieve not only achieve net zero energy, but they might have to go above and beyond. So the more buildings that aren't able to achieve it means that the more that the other buildings have to step up and pick up their slack. So we're in this as a whole community. Based on that idea, there will be different solutions for different building types. The city's goal is to write an implementation plan that requires a fair and consistent level of effort across all building types, sectors, and neighborhoods. And in order to write that implementation plan, we need stakeholders like you all to help define and refine that pathway. Accounting in Denver. Denver's goal is to achieve net zero emissions. Again, you might be asking yourself, isn't this presentation about net zero energy? Well, yes, that is true. Denver is looking at achieving their net zero emissions goal through energy instead of carbon. The reason for this is that carbon tracking is a lot more complex, and Denver already has the energy rating and reporting infrastructure in place. There is an electrification plan already being mapped out for Denver as well. This has been carefully looked at due to, or the electrification has been carefully looked at due to heating and hot water heating being the two largest contributors to Denver's emissions. So the thought is by eliminating combustion on those two items alone should bring Denver's emissions down quite a bit. And the last thing on this slide talks about renewables. Denver wants to have the renewable capacity locally rather than buying RECs from other jurisdictions. So any renewable energy that is being utilized for net zero energy, Denver rather have that be in the city and county of Denver. So it'll take everybody to get on board to make net zero energy work here in Denver. And Denver has committed resources and staff to get there. What we need is the community to support the efforts as well, from marketing, education, via case studies, advocacy, training, you name it. This is what will make the transition to net zero energy a lot smoother if we're all helping to support one another. So we're going to look at a few case studies. So that's a little introduction of what net zero energy is in Denver. Now we'll look at some successful case studies on how to get there.
Thanks, Kevin. Yeah, let's look at some examples. Specifically, we're going to look into, briefly look into process and technology, but also the contracting aspect of how NZE was achieved. All of you at this point know about NREL's Research Support Facility. It's such a good case study that we decided to still include it. I will not spend too much time on building features, but high-level overview is that there were three things that we can take away from it, is that building energy efficiency is still the foundation for net zero energy building. Within building energy efficiency, we can pursue passive strategies and active strategies. Passive strategies are a lot of times cost effective, they are long lasting, they're worth investing in. Of course, there's a lot more analysis involved, but in general, it's the strategies that last long, and they can be from every building system aspect, whether it's envelope, mechanical, or electrical. A lot of times they can also be the cheapest. Certain envelope strategies are the exception, but in general, that's how it is. Once you go into active strategies, it's important to focus on recovery. So recovering energy, where can you reduce and optimize the use of energy? Where can you recover heat? What are the strategies you can use in your mechanical and plumbing systems to recover that energy so it doesn't go to waste? And then the other aspect is looking into materials, because nowadays we are looking into the operational aspect of carbon emissions and how we reduce carbon emissions by looking at energy use. But if we zoom out a little bit and look at it holistically, we also want to look at materials and how we can reuse and how we can repurpose things, relove. So these are the main strategies that we use for NREL's design process. And then we're going to go into a little bit more into the contracting aspect. So NREL, RSF, the owner being NREL and Department of Energy, have used the design build process, specifically performance-based design build contract with award fee. So the owner sets the fixed price, develops documents, and lets them know what the priorities are, and within the priorities, firmly sets tiers tiered aspect of what the priorities are, what are must-haves, what are nice to have, so that the team, everyone in the team knows what the priorities are and the hierarchy within the priorities. Also, during the process, the owners provided the stipends for shortlisted teams. There were only 3 of them, but they were all at least partially rewarded for their hard work to come up with the preliminary design. Even though only one team won, the owner got to claim ownership for all the designs, and if it was decided that it was worth pursuing a certain aspect of the design that did not win, they could still use it. And the key to success in this process is clearly defining owner roles and responsibilities. So it requires pretty active involvement from the owner, which NREL and Department of Energy coped with very well by assigning specific roles within specific building systems and strategies. So what is the extra perk here? So they had an award fee incentive program within the contract that awards the team for going above and beyond for certain aspects of the design and construction process, safety being first. That's one area for superior performance. Also things like design, commissioning, quality of work and construction, responsiveness on how the team interacts, communication, and sticking to schedule, beating schedule or being on schedule. So that fee, the total was $2 million, and it was split up by design and construction schedule. So for preliminary design, design development, construction, and closeout. What's worth noting here is that even though a fixed percentage of the fee is assigned for every phase of design and construction, even if team did not achieve or did not hit that milestone for that specific phase, the $2 million, whatever remaining after being awarded, still stayed in the pool, so it just shifted to the next phase. So say hypothetically, if none of the milestones were hit in the first 5 stages, $2 million was still available in the last one, which was post-occupancy. So making sure that the modeled and expected EUI numbers hit and other criteria. So this encourages cooperation, it encourages optimism and being interested and involved in the process, no matter which phase of the project you're in, even if it's post-occupancy. And then going into costs, one thing to mention is in projects like this, when it's not just typical traditional building, but we're pursuing a net zero energy, some of the fee percentages may shift from one discipline to another. So as you can see on the right side, the architectural fee ended up being higher, mechanical and electrical and structural slightly lower. And primary reason for this is the scheduling and planning for the project is slightly different. So it's more front-loaded, so architectural plays a bigger role. One word of caution for processes like this is to make sure that the mechanical, electrical, plumbing, and other consultants in the project are encouraged to pursue passive opportunities, that they are encouraged to pursue systems that are cheaper. In order to do that, we do not want to tie their compensation on the cost of the MEP system. So maybe looking at it more creatively, we want to inversely add an element of inverse reward to the MEP system cost, or look at more alternative options to compensate our consultants.
All right, I'll take it from here, Aksul. Thank you. Okay, so jumping into another case study, we've got Boulder Commons here, which is a project that consists of 2 commercial buildings totaling 100,000 square foot about. This includes office space, restaurant, coffee shop, and a community gathering flex space. The integrative design process with this project brought together a knowledgeable team to reduce those costs from the beginning and ultimately achieving a net zero energy building. Throughout this process, they immediately identify the project's goals of sustainability, community connection, and then also cost-effective solutions. What is unique about this project is that it is Colorado's first NZE lease, and the structure built a strong business case for both tenants and landlords to actively contribute to meet the development's goals. The lease allocates a budget for factors like energy use or transportation that could make or break the development's ability to meet the energy demands through on-site renewable energy sources. There's also incentives to stay within, for example, the plug load energy budget, which was 7 kBTUs per square foot. And so if that budget was exceeded, there's a fee that's charged to offset the overage with no renewable energy certificates, RECs, in other words, and it's required that the tenants then speak with the landlord to discuss ways to more proactively manage their energy use. The NZE lease also enabled offsets. So basically, any energy purchased from the utility is required to be offset with those RECs, but instead of committing to a single compliance path, it was negotiated that alternative offsets for energy could be used, such as community solar, energy efficiency certificates, or green power directly from the utility, and then a whole bunch of other clean energy attributes. So because of the NZE lease, they actually anticipated a 10% greater tenant retention and overall higher occupancy rates. So this led to increase in revenue that eventually ended up helping cover the cost of PV over the next 12 years or so. As I showed in the previous slide, this project was completed in 2017. So still got a few more years on that. And in addition, when the property is sold, the anticipated premium is at $33 per square foot for the developer to regain. And then to determine the fair energy charge, Morgan Creek Ventures, the developer and landlord for Boulder Commons, studied energy bills of all the other local properties in the area and found a range of $1.80 square foot through $2.50 square foot annually, and then used that to lower the range, used the lower range of that and added it to the base rent. So MCV actually pays the utility bill, and then any reduction in energy costs beyond that $2 per square foot goes to the building owner to help recover those PV costs even faster. This also, provides an incentive for the owner to continue reducing those energy costs over time, investing in new technologies like energy storage, demand response, load flexibility. So that would increase their return on investment and by reducing those demand charges. Sorry about that. So just jumping into some of the building features, you'll see this pretty common in a lot of NZE buildings is this triple pane glazing, very low LPDs with lighting controls, and highly efficient VRF system with ERV. So since Boulder Commons is a 4-story building in a cold climate, it was not able to achieve NZE through rooftop PV alone. So they decided, rather than pursuing those deeper energy efficiency measures, it was more cost effective to install PV on the southeast facade, which you can see in this image here. And that also had the additional benefit of offsetting exterior cladding costs. So for example, the vertically mounted PV cost approximately was about $84 per square foot, but since it eliminated the need for the metal panel wall system, which costs $42 per square foot. The incremental cost of the PV was only $42 per square foot. So the southeastern facing PV does actually have a lower performance than the rooftop solar by about 28%, but due to its vertical orientation. But since you're canceling out the metal cladding costs and the incremental cost ends up only being $42 per square foot, each unit of energy generated from the vertical facade on the southeast side is actually a faster payback than the rooftop solar PV, which I thought was interesting. And then looking at a quick glance at the costs. So the UI before the PV was 26 kBTUs per square foot. The overall PV system is 575 kilowatts and produces enough to offset the building's annual energy use, excluding the restaurant. And looking at this, it was outside of the PV, the overall NZE building had a hard cost premium of about 12% when compared to code compliant office buildings in Boulder. Okay, so then we're going to look at Denver Water's new administration building. And this one, it was completed in 2019. So they're still getting performance metrics on the building, but just to give you a quick overview of how they were successful in creating a building that achieved NZE, LEED Platinum, and a bunch of One Water strategies. It culminated nearly a decade of planning and years of construction. So that's where a lot of that early on planning came into play. From the beginning, they engaged building occupants by holding a series of events to gain input during the conceptual design phase. Employees, executives, developers, and construction representatives developed alternative layouts based on the occupants' workflows and requirements as well. And because they were able to engage with the building occupants, it actually ended up in a more efficiently designed building, saving thousands of square feet. And as you can imagine, close to millions of dollars in construction costs. So Denver Water did appoint a core team of employees that helped to advise throughout the project. So the team met weekly, coordinated everything from the development to the marketing materials of the building. And then with the integrative design process, as I said before, they were able to achieve that LEED Platinum and NZE target. They also worked with Excel through their EDA program and saved over $400,000 through additional energy efficiency measures. So this is some of the building features that you'll see in Denver Water. They've got a PV system, radiant slab seating, radiant slab heating, daylighting. Some things that do make it unique is the gray and black water recycling system, which I know was definitely tricky with Colorado's water regulations. So they can be used as an example moving forward, which is great. And then high efficiency chillers and air source heat pumps with backup electric boilers. And then Denver Water actually tapped into one of the adjacent potable water conduits from Denver Water's own water supply as a variable temperature heat sink as well. So as you can imagine, a lot of these building features takes a lot of coordination. It was facilitated between team members to get these complex systems to actually work as intended. So I'm going to go ahead and launch this poll question. Have you worked on an integrative design process, or do you think you have? Just let you guys respond, and then I'll keep moving on and I'll touch back. So from the beginning, in order to get a net zero energy building and think about cost control, it's important to prioritize project objectives early on and use a delivery method that promotes that integrative team throughout the design and construction. Throughout the design and construction, you want to balance cost and value, consider those life cycle costs impacts and allow for cost trade-offs among disciplines, and just communicate and keep those energy modelers in the loop. And so rather than asking me how much will a zero energy building cost us, maybe we shift our thinking to, okay, how can we achieve zero energy within our budget? And then just some barriers to pursuing NZE. You're looking at, Denver, I know, is working to lead manufacturing companies to develop more affordable technology and equipment by setting NZE standard and moving in that direction. There is also a stigma that if you don't achieve NZE, the company will look back, right? So it's important to celebrate your successes as you hit them, as you hit those milestones. And even if you don't reach NZE, communication with your developer or building owner can also help set up those expectations. And then reduce risk by planning ahead with a structured process like integrative design. That process could also potentially help mitigate or maybe limit the amount of items value engineered. I'm going to go ahead and end the polling here and share the results. So it looks like we've got a lot of people that have not used it yet, which is exciting. I'm about to walk through, give you guys a brief overview of what that process looks like. And I know we have a lot of building officials, so maybe it'll cue you in a little bit to what the design teams are looking at when pursuing a net zero energy building. So there we go. So, right, how does the process change when pursuing NZE? The integrated design process is a collaborative process that focuses on design, construction, operation, occupancy of a building over its complete life cycle. So some of you might be familiar with IDP, but it's called something different. And IDP can be tailored to your company or your project needs. So why am I talking so much about IDP? When considering a net zero energy building, an integrative design process can reduce risk through feasibility studies, through early identification of those conflicts. It can streamline the process by maybe minimizing those items that are value engineered and having less misunderstandings through continuing communication. And then a lot of the cost savings. This is what's going to drive why people use the integrative design process. And that's why you look at life cycle cost analysis, where it takes in consideration sometimes the employee productivity on top of the energy savings, custom construction cost reduction. Hopefully there's less change orders with more collaboration up front. And then mechanical system cost reduction as well by considering passive strategies. So this is just a quick comparison of a traditional design process versus the integrative design. And the integrative design process requires more time and collaboration during the early conceptual phase and design phases, where you might have maximum flexibility to design and coordinate everything and make changes early on and get input from key stakeholders from the beginning. Conventional planning and design and building operation processes can sometimes fail to recognize that building components are part of a larger, more complex system. So sometimes you might be solving for one problem and it leads to other problems elsewhere in the building system. So IDP breaks down those disciplinary boundaries, which can lead to more efficient solutions. And then also looking at life cycle costs of the building will result in more cost savings over time by selecting those efficient and equipment systems and optimized strategy rather than just basing it off of your upfront costs. So I'll go ahead and walk you through each of these phases. So with the pre-design is really exploring the relationships between the project and its surrounding environment. Select optimal choices for site occupants and the building owner. Sustainability goals might be set during this phase, covering economic, environmental, or social performance criteria, whatever the goal is of that building owner and the team members, because all core team members are really involved in this pre-design phase. And then setting fees and incentives for the teams. Aksul spoke a little bit about the uniqueness of RSF's fee structure. So there's a lot of opportunity there to incentivize your team through that fee structure as well. And you're going to continue to see planning key meetings throughout each of these phases. It's really important to meet with your team constantly when you're pursuing an integrative design approach to really make sure that everyone is on board from the beginning with the goals and they're clearly identified. So in a traditional process, you would see more of a hierarchical approach where the prime, typically a GC or an architect, is the one that coordinates. But in an IDP process, there is still one organizer, but it could be someone from the GC or the architect, or it could be someone from an energy consulting team or the engineering side. Regardless of who it is, everyone is equally contributing, resulting in a more interlinked team that gets support from the building operators, manufacturers, commissioning agents, and other site specialists. Oops, a little too far. There we go. So jumping into phase 2, this phase is really for thinking outside of the box, exploring innovative technologies, new ideas, fresh application methods, working towards those goals set in the pre-design phase. And then also preliminary models might be run. And so that's where this slide comes into play. The preliminary model might be an iterative model where you're taking a lot of different approaches, massing optimization, finding overall systems that your team wants to consider. That's really in this early phase over here. But there is also code compliance incentive programs, predictive performance and certification models as well. I do want to point out which this may lead to, right? So if you're pursuing an NZE building that's also going for LEED Gold or LEED Platinum, you will need an energy model. So then we look at design development, and design development is a time for a firm to validate choices, and from the schematic design concept phase to bring over to the client for approval. All electrical, mechanical, architectural systems are then assessed and examined based on their performance and impact on other systems, and seeing where you are in terms of your goal and targets. And then again, that iterative analysis is key, working with your energy modeler to hone in, okay, what makes the most sense for our building? If we reduce the amount of windows in that building, can we reduce our mechanical system size? Evaluating and optimizing the building further. Construction documents, which I know is very similar to the traditional phase. So this is just reviewing the process, what has been achieved throughout the earlier phases, and validating those design and impacts across all disciplines. And so in phases 3 and 4, that's the DDs and CDs, we start to refine the predictive model to match the actual performance model a little bit further. And this is where we want to see if there's any discrepancies occurring, looking for clues within the load distribution and seeing, okay, are the building schedules or occupant behavior that was assumed correct for how the building will actually perform? And a lot of the times, as we hit that CDs or even a little bit before, that energy model can be used to size PV, especially on net zero energy buildings. Phase 5, we're looking at construction and commissioning, and many factors must be considered to ensure that the goals of the project are carried through completion. You keep hearing me say that. But there's always going to be those inevitable changes, right? So it's important to make sure that the changes or the submittals that we receive or the RFIs are lining up with the sustainability goal. So that's why it's also important to have those goals set in the beginning, make sure everyone that's working on the project has a clear idea of what we're striving for, and have that included in the specifications so that whatever is submitted in those submittals match those specifications and goals. And then by the end of this phase, the team will have have achieved a finished, fully functional, and well-commissioned building, hopefully ready for occupancy. And here's the building operation phase. This is a key transition phase during which the design team must take on the responsibility for the knowledge and the building operation and system, and make sure that it's transferred to the building owner and operations staff. And it's also important to debrief, look at those tools that are making sure that those tools for monitoring the ongoing building performance are acting appropriately, and host debrief meetings. Celebrate your success for developing or building a building to NZE standards. All right, here is another poll question for you all. What do you think is the biggest barrier to using an integrative design approach? I'm going to move on to the next slide here. That's post-occupancy. So it's a bit different from the traditional design process, where integrative design does not end where construction is complete. Occupants have moved in. The IDP enhances the entire life of the building through effective maintenance and operation and measurement and verification, commissioning, recommissioning, and building performance evaluation. The post-construction can also provide those feedback loops, which facilitate continuous optimization of the building's performance. This phase can save money by identifying problems and providing an opportunity for resolution. So, if you predicted the energy model for the building to be functioning in a different way, okay, what are those differences? Are the controls set as intended? So I'm going to go ahead and end that poll. And a lot of you said timing, which I have to agree with. All of these can be barriers, but timing is probably the largest one, and not starting early enough, not getting your team on board, and having those goals set. So that is the last of my section, and I'm going to go ahead and pass it over to Aksul for the approach.
All right, thanks, Erica. So we're going to talk about how to approach designing and building a net zero energy building. Just a quick recap. By Denver's definition, net zero energy new building is highly energy efficient, all electric, incorporates renewables and demand flexibility. Highly energy efficient being the foundation for various reasons, cost effectiveness being one of them. So why do we want to achieve net zero energy as a team member, whether you are a real estate developer, MEP consultant, architect, owner? Present day drivers, I want to gain more expertise in new technology and methods and practices, because these new technology and methods are going to be the status quo in the future. As more municipalities, cities, countries, and the whole world move to net zero energy building construction, this will be the new norm in the future, so we want to be ready. We want to align with our goals as a company, both internally and externally, oftentimes incorporating environmental, social, corporate governance, and also motivating workplace and providing best value to the client, which is the best marketing tool. Speaking of the future, in the future, this will be a code compliance requirement. So this will be how we will have to build new buildings. So hopefully that's a motivator enough. What are the challenges and opportunities? As Erica went over earlier, involvement, is very important, and you guys confirmed it via your poll answers. Cost effectiveness can be challenging, or how we go about it, how we approach it. Related to that, it's an opportunity. We would like to shift our thinking, have a paradigm shift from thinking about initial cost of the building versus life cycle cost and the added value that it brings, whether it's monetary or some intangible holistic value that it brings to the building and to its occupants. What we can do with the renewables, how can we incorporate it to the building such that it's cost effective and is not too detrimental. Another opportunity and challenge is shifting away from more traditional equipment and design options that oftentimes certain building type, as soon as we find out what a building type is, oftentimes we just think about, 1 or 2 MEP systems and very limited amount of methods and strategies we incorporate. How about we move away from it and be more open-minded and look at some more passive and active strategies. So I'm going to quickly go over all the 4 criteria for what a net zero energy building is for Denver. First and foremost, highly energy efficient. Pursuing this is the best and most cost-effective way of achieving net zero energy building, be it a passive design strategy or an active design strategy. When we talk about passive strategies, we mean building orientation, shape, mapping, shading, things that we decide and things that happen very early on in the design process. But nevertheless, it's very important. This is the most cost-effective way of affecting building energy efficiency, and it happens early on. Choosing wall type, fenestration, do we want to have more thermal mass? All these questions are good questions to ask at the beginning, and ideally with everyone involved in the team. As far as active design strategies go, we want to focus on the most impactful strategies, and energy modeling, energy consulting can be very helpful in this. We want to identify what is the biggest end use that has the highest impact, and what are the best strategies that affect those end uses, and we can focus on them. We want to talk about new emerging equipment and design solutions, specifically when it comes to space heating and service hot water heating, because as we will talk in the next few slides, they also have to be all electric. So that is an added challenge for our climate zone. And with that, rebates and incentive programs are great opportunities to help us to involve the energy consultant or help us offset the first costs and the consulting costs. For commercial buildings with Xcel Energy, you can incorporate either energy design assistance or EEB programs or prescriptive multifamily programs. For residential, these are newer options, prescriptive options. If you will go for air source heat pumps, you have a few options there. You can get a rebate from $600 to $1,000, depending on what kind of an air source heat pump you have per unit. So, and one of the options is a mixed fuel heat pump. What's great about it is if your client or if you are hesitant about just going all electric, you want to have a backup of natural gas heating, it's a great option. So what happens is natural gas would kick in, heating would kick in at 35 degrees or lower. So Xcel would still provide rebates depending on heat pump type in the range of $600 to $1,000 and $800 for water heating heat pumps. So it's a great opportunity to not only make sure it's highly energy efficient, but also all electric and get rebates for it. So touched on this, opportunities and challenges, making sure you explore all the options that are available. Luckily, we have more and more options as days go by, but it's still a relatively newer technology. Look into cold climate heat pumps and what else is out there, what else is available, and focus on the peak shading opportunities. Once you identify what your end use is, that would help a lot with focusing on the right things. And of course, continuously revisiting highly energy efficient strategies. These are some of the suggestions. Next slide, please. Renewable energy and electricity is another criterion for NZE. And looking at strategies and suggestions is trying to shift your thinking from thinking that renewable energy is an added feature, it's a perk, thinking that it's a necessary design component in the building system because it produces electricity. Just like any other system has a function in the building, renewable energy, PV panels have their function too, therefore they are a necessary design component. Consider early on where you want to place the PV system. Is it on site, specifically on the roof or parking lot, or where else can it be placed? When we're talking about NZE, this can become more of a challenge, especially the higher rise, mid-rise buildings. And continuously revisit the previous criteria, especially the highly energy efficient option. It's the best and most cost-effective way to address this and to make sure your renewable energy allocation is optimal. In terms of how you meet this requirement, it can be, of course, on-site, but you can also pay into the Renewable Denver Community Solar Fund, and the details are still being determined and will be shared once known. And demand flexibility is another criterion. Some suggestions. In the upcoming code cycles, there will be more detail about this, but what we know so far, and based on that, the suggestions are just going beyond the requirement. This will add the element of resiliency, especially with super hot summers that we're experiencing, more extreme weather, and the reliability of our grid. It's more and more important to consider resiliency as a criterion for building design and construction, and the added value it brings to the real estate. And not any less important, as as electric vehicles are becoming more and more popular, it's almost a requirement to think about demand flexibility and potentially adding batteries or other opportunities to the building. And just a recap for integrated design process, cannot emphasize enough, timing is of the essence. Make sure you begin early and then continuously collaborate with everyone in the team. And poll question. Have you seen any of these traits in a successful project that you worked on? Now, while you answer, I'm going to recap on the critical issue, the addressing costs with clients. Again, it's important to shift and change our traditional view that a building cost is the first cost only. No, building cost is actually the life cycle cost. In a way, we are reducing risk by addressing life cycle cost of the building, because first costs are today, OPEX costs are in the future, and if we address everything, we are addressing risk. So we can change our thinking about it. Also, integrated design process would help with addressing costs as long as you make sure it's early enough, and consider looking at other financial incentive options or fee structuring options for design team members, so you actually encourage lower cost passive strategies instead of discouraging them by providing your fee as a percentage of the total expense. So look at other alternatives. All right, we have the results. So luckily, most of us have seen these traits in at least some of our projects. So that's encouraging. Thank you.
Thanks, Aksul. So we only have a couple more sections left, and then we'll open it up for Q&A. So I just want to recap what we've gone through so far. We've gone through the definition of what Denver calls net zero energy. We've gone through some of the strategies and approaches that you all can take in your projects to get there. And then we also have given you a few successful case studies in and around Denver to show you what they went through to get there. So in this last section, we're going to focus on the Denver codes. So up until this point, we've talked about how the project team is going to get there. A lot of times, you all mentioned it in your poll that these projects just don't have the time to go through this lengthy design process or design stage. And so a lot of times that gets put to the back burner. And so it's really then up to the code to make these teams get on board with the net zero process. And so this is how Denver is going to see or do their part to help bring these design teams, the designers, on board if they aren't going to do it voluntarily, if you will, because everybody has to meet their goals. So let's go over the Denver requirements. Currently, we have the Green Building Ordinance and Denver codes have to be followed, the Green Building Ordinance. And then there's also the Denver Green Code. So two different things. Green Building Ordinance, which every building has to follow. And then there's Denver Green Code, which is a stretch code and optional. One thing that I like to point out, if we go to the next slide, is that the Denver Green Code is more of a stretch code that will more likely become the base code for the next code cycle. So it's Denver's way of giving everybody, the community, a heads up. Hey, look, we don't want to throw everything onto you brand new, and then your project doesn't know you don't know how to achieve code compliance. So we're going to give you a heads up. And if you look at the Denver Green Code, that's going to tell you that pretty much that's going to be involved in the next code cycle. So maybe you should start thinking about some of those strategies in your buildings and designs moving forward. The Denver Green Code adoption process, the Denver Code adoption process, if you all are looking how to get involved, it's pretty straightforward. If you follow this, the next slide will be exactly the same, but for residential. The city develops proposed amendments, basically a baseline code that they think is going to keep them on track to that trajectory that Amber showed in the beginning of the presentation. They have to get to their energy goals. So there's going to be a baseline. Once that's established by the city, that's going to be published. Then the public is going to be allowed to comment on that, propose amendments, changes. They think this is unfair or the technology is not around yet. And then that will go to a technical advisory committee. And that committee will review all those public proposed amendments and vote on them, whether or not they should be included in this round or modified or what have you. Once that happens, then the city will publish the approved amendments, and then those will go to city council for a briefing and vote on whether or not those would be brought into the code cycle. So Denver Green Code, very same process, which is the next slide, sorry. Same exact process, it's just the Denver Green Code, which is the voluntary code. So the last slide is a baseline of what we need to do, and then the Green Code is the stretch. Next steps for future input on codes. There are some working groups already scheduled for this year. You can see on the screen. The groups include some energy efficiency groups, some sustainability groups, or just general ideas groups. There's also code committee meetings already in the works. So there's a lot of things in process right now and getting set up for this next code cycle. So the last thing is that I'll touch on is the future of net zero energy. Again, those are those 4 items that that Denver said that we have to have. And here's a little graphic that is really balancing those 4 things to make sure we're good to go and meet net zero energy. So if we look at the timeline of what that looks like, here's the commercial code timeline. If you look at this, so we talked a lot with engineers, architects, designers, consultants, all on the phone. We spent a lot of time speaking towards those, but now the code officials on the phone, this might be the section you want to listen to. It's not that the other folks on the phone can't be involved on this, but this directly impacts what you do from day to day. So this is a proposed timeline. And you can see right now, we're in 2021, and we got the 4 categories that the city and county of Denver says that in order to get their goals, these are the 4 things that we need: highly efficient, all electric, renewable energy, and grid flexibility. So as time goes on, you can see it starts to step up, or we start to ramp up, the city starts to ramp up their demand for getting to net zero energy, which means if you look at all electric ready in the 2021 code cycle, that simply is just introducing the concept to the community. Conduit and panel space is what we're calling is acceptable for all electric. You're all electric ready. But once you get to 2024, all electric definition changes. So we're going to say the city is proposing that all electric means the entire building is electric except for water heating. And then you look at 2027, the entire building's all electric. So you can look at this. I won't go through every single item. I think the other interesting one here is the renewable energy percentages. So we'll see that we're trying to hit, with this proposed plan, trying to hit the goals before 2030. So you'll see a lot of the targets set to be achieved in 2027 code cycle. So it has time to catch up. And here's a look at the residential code. If you're familiar, the residential proposed, again, this isn't set in stone, proposed timeline to get to City and County of Denver's goals. So again, I won't go over these too much, but a highly efficient commercial and multifamily building, we have to develop performance targets. One thing that I want to point out in the slide is that performance verification is going to be a big part of the code cycle moving forward. Right now, we have predictive EUIs, which are great when we're modeling, but the actual performance is what's going to either make or break the City and County of Denver to get to their goals. And so there is going to be a performance verification aspect implemented into the code. So look for that coming out. Just this morning, I was talking to one of our energy modelers who's been modeling for 30 years, and he said that one of the most unpredicted loads in an energy model is the heating load. And so it's great to have these predictive models, but once you get to the performance, the actual how the building is being used, that's what we're seeing a big discrepancy. So there is going to be some verification aspect to that. Here are a few commercial and multifamily energy targets, if you're familiar with these. They're broken down by building type. So we'll have small hotels, offices, retail, warehouses, multifamily. And you could see, again, as we get closer to 2030, the EUIs are going to get lower and lower. And 2027 is really where we want all of our targets to be locked in and ready to go. So by 2030, we've met our goals. You might be asking about, then we have the other commercial buildings, which aren't in those sections there. They have their own, excuse me, their own category on EUI, except for they aren't looking necessarily at an EUI, but you are going to look at percent better or percent savings over baseline modeling. So there's a couple different ways that they're going to we can look at approaching that. Residential code energy targets, if you're familiar with that, here are the the sample timeline right now. Again, these are not set in stone, but again, kind of throwing them out there so everybody gets used to them. All electric, here we go. These are, again, proposed pathways. I won't spend much time on this one, but really drives it home for the different building types here. So we're the last one we're really focused on, again, trying to do 2027, where before it was just physical space in the panel, and you had wiring and conduit. Again, getting everybody ready for this change. Denver wants to promote the addition of renewable energy capacity. That's how we're going to achieve, or the city and the county of Denver is going to achieve net zero energy by having renewable energy. And so here are those targets. The options would be on-site solar, but we know, the city and county knows that not every single building is designed in such a way that that works for them or is feasible for them. So there's other options where you could pay into a fund that the city will manage a community solar garden. So they're looking into all these options to help get everybody on board for net zero energy and really make it achievable for everybody. And then grid flexibility. We want to make sure that there's demand response capable equipment to handle anything that's going on with the grid. So with that, hopefully you all learned some of the updates that need to happen in the design process. Now I'll turn it over to Amber with the city to explain how you all can get involved in the process on their end.
Thank you, Kevin. So there's a couple different ways to actually get involved. We have a number of task forces and committees. So previously we had the Climate Action Task Force that is now complete, but they gave us climate recommendations and equity considerations for our work. We now are working with the Energize Denver Task Force on a building performance policy for existing buildings. So that's ongoing if you're interested in the existing buildings work that we're doing right now. And then we have our Sustainability Advisory Committee gives us input into all the work we do at the Office of Climate Action, Sustainability and Resiliency. And as part of that, we have a High Performance Buildings and Homes Committee. That's a subcommittee of that group. Our chair and co-chair actually sit then on the Sustainability Advisory Committee, but we hold those once a month. And if you're interested, please feel free to reach out. I can definitely, right now we're holding those as open meetings. So anybody that would like to kind of understand where our high performance buildings and homes work is going, that's a great group to get involved. We often will ask questions and have them help us refine directions that we're going. We also have a number of studies and efforts. So we did just put out the Net Zero Energy New Buildings Implementation Plan in January of this year. And then we're trying to bridge the gap a little bit between that and then the code adoption process, which actually is just starting now. The things we're looking at is, the first thing we're looking at is to understand first costs a little bit more in detail. And so we are working on an affordable housing zoning incentive study to understand first costs of NZE in more detail. And then we have a communication plan for developers where we're putting together a comms plan specifically for developers on net zero energy in new buildings and homes. And then we have this training as well. And I will just mention this training is recorded, as you know, and it will be available online. So we're going to put it on our YouTube page. So look for that. And in conclusion, really, net zero is really healthier for our environment, and it's more comfortable and can be lower cost, with a couple caveats. So when an integrated design approach is pursued and the life cycle cost of the building is considered. And with that, we'd love to hear your questions. You can type in the Q&A. I think already may have one. And I think I'm turning it back over to Erica to help facilitate the questions.
Great, thank you, Amber. Yep. So if you want to go ahead and write any questions in the Q&A, or you can go ahead and raise your hand and I can unmute you to ask us directly. It does look like we have one question so far, asking us to speak to all electric utility cost versus multi-fuel buildings.
Yeah, I can work to answer that. So I'll answer that in a couple different ways. The three cost studies that we had shown were showing lower operating costs of the all-electric building compared to multi-fuel. That said, and within our plan, you can actually get into all of the details of those cost studies. We're also doing actually a specific renewable heating and cooling plan, which is basically an all-electric plan for existing buildings that really details all electric costs by system type. And that's going to be available next month, and it will have a lot of cost data. I know energy modeling went into that. Jan Kelleher, my colleague, is leading that effort. So we plan to see that out soon, and it will really have a lot more detail in it than we have available in our current plan, even though we do go through those cost studies that we that the slides of the cost studies, we do have details of those in the report as well.
Great, thank you, Amber. It looks like that's all our questions. So we'll stay on the line for another couple minutes. If anyone, oh, here we go. We got one more. Does the ERI component of the residential sector require you to use REM-rate or ecotrope?
So right now, the ERI the proposed ERIs that we have within the plan are the ERIs that are based on the actual I codes. And yes, usually to get those numbers, you need energy modeling software. It doesn't require a specific software. Any software that's approved by the by IECC can be used in order to actually do that. But the ERI targets do have to be calculated by energy modeling software. So hopefully that answered your question.
So.
And actually, I'm going to add one more thing. One of the other keys to this too is actually that we also have a prescriptive path that aligns with the targets in the performance path. So I should actually expand that comment, because you won't necessarily have to use the performance pathway. We are going to align some of the requirements so that a builder could still use the prescriptive pathway and essentially get approximate equivalent performance is the current proposal within the plan. But if you do use that performance path, you would have to use software. So hopefully that clarifies that.
Yeah, and Amber, I'll make a comment on that as well, that even though if you follow the prescriptive pathway, remember one of the key things that we spoke about today is the integrative design process and the iterations of modeling. Is really what's helped these projects that we've seen achieve net zero energy. So even though it's not a requirement, if you follow the prescriptive pathway, it'll definitely help your project achieve net zero energy.
Great, thank you both. I mentioned a plug load goal of 7 kBTU per square foot. What are we typically seeing now? That was from the Boulder Commons case study that I presented. And it does depend on the type of building quite a bit. You know, typically a office building, you're going to see a lot of computer plug loads in there. So it does range for a net zero energy building that's targeting a EUI of 26 kBTU per square foot. 7 is probably accurate for in terms of proportion to your overall EUI. But it really depends on what EUI you're targeting. And there's also different like receptacles that have the on-off controlled now to kind of help manage that plug load as well, along with a bunch of other things. I don't know if anyone else has anything else to add to that.
I can add a little bit. I can't really correlate BTU per square foot to watts per square foot. I don't have that memorized, but we are at a point when lighting loads are lower and plug loads are higher. So it's pretty common and across all buildings, like this is on the lower end to see 1 watt per square foot. But like Erica mentioned, it really depends on the building type. Offices, how dense is it? How many people? Same with housing, right? Even the square footage, for the same square footage, you can have a highly variable plug loads depending on occupancy and just the number of loads. But overall, I think if you're looking for a rough number, like I would say 1 watt per square foot, but it's highly variable.
Right. Yeah. In an energy modeling software, I feel like it depends. You know, it has the ASHRAE defaults in there, and it's usually like 1 to 1.5 watts per square foot. Of course, if you're talking more about a kitchen plug load, that's going to be quite a bit higher, more into the 3 watts per square foot or 4 watts per square foot. Okay, I think that's it. I want to thank you all for presenting today, and I thank you everyone for attending.